Ball screws. It isn't just a fun thing to say, it's what we're going to put into this milling machine today. Though, it is a pretty fun thing to say. Ball screws. Welcome back to Cloud 42, I'm James. You will remember that we are in the middle of converting this Precision Matthews PM728 mill to CNC using a Masso CNC controller and ClearPath motors. There is a playlist linked down in the description and somewhere up here. We are done with the electronics. We've got the cabinet built. We've got everything wired. We should be ready to go on that end. And now it is just time to do the mechanical conversion on the mill. And we're going to start that today by installing a set of double nut ball screws in the machine. Now, this build is sponsored by Precision Matthews. They did provide the mill. They did provide the ball screw kit that I'm going to be installing today. There is a discount code down in the video description if you are interested. Now, I normally like to be prepared before I turn on the camera to shoot a video. I want to have all the parts I need. I want to have a detailed plan. I want to understand everything that I'm going to encounter so the project will go smoothly. I have not had the opportunity to do that for this part of the project, primarily because I don't know exactly what I'm going to find when I disassemble the mill. I'm pretty sure the ball screw kit is going to fit just fine, but what I don't know is about the oiling system. There are oiling ports on the ball screws. I do plan to hook them up, but I don't know about routing for the tubes. I don't know about clearance for the connectors. That's always a little bit of a wild card when you get into a conversion like this. So let's just jump in and see how it goes. First thing that needs to come off of the machine is this chip guard just to get it out of the way. Otherwise we will be fighting it all day. The next thing I want to do is actually remove the head from the machine, and that's just to get the weight off of it. We don't really need that for putting in the ball screws. The slide on the back here is the only thing we need, and getting that off the top will also reduce the weight in case we need to tip it or access the underside of it. Now, normally I would do this with a vise on here. I don't have one right now, and I've got a board here set up with a 2x4 screwed to the back of it. Clamp that in the vise, and it gives you a nice stable platform to bring the head down onto, but I'm just going to use the board. Now the whole point of this is just to have some support for the head so that when I loosen the bolts it won't fall, and then I can lift it off when I'm ready. We'll take off the quill handles just so they don't get bent or broken. That was actually kind of heavy, it turns out. This is the double nut ball screw kit from Precision Matthews. And while it does come with instructions, they are fairly limited. What you actually get is an exploded diagram of the assembly, which technically is everything that you need. We've got the whole stack ups on all three of the screws showing exactly where the bearings go, how the motors mount, and all of the hardware. It is pretty tiny, but if you spend your time studying this, this actually does have everything that you need. There's nothing here about procedures though, so we'll just have to figure that out as we go. There are some notes here about the bearings and exactly how annular contact bearings work and about the markings on the faces. We'll get to that when we get to that. The kit comes with 3 ball screws, one for X, one for Z, and one for Y. And these are double nut ball screws, which means there are 2 ball nuts on each screw that are preloaded against one another to reduce backlash. Now these are C5 rolled ball screws. The ones that I used on my Grizzly mill several years ago when I did that conversion were C7 ball screws. These are C5, which are quite a bit more accurate. And the main difference is that the lead error is going to be lower, and that actually makes it easier to load the two ball nuts against one another. The way these work is they have recirculating ball bearings. So there are ball bearings that ride in the grooves of the screw, and there are corresponding grooves inside the nut. And this one's got, looks like 1, 2, 3 circuits. So 3 rounds of balls that go all the way around. And they're chosen so that the fit is very, very tight, and there should be as little backlash in this nut as possible. But to make sure there isn't any backlash, or to reduce it even further, this is a double nut ball screw, so there are 2 independent nuts, and they have these little shims between them. And these shims are ground to fit, and they fit in here, and they preload those 2 ball nuts in opposite directions to take out any of the backlash that would be in there. Then there's a little plate here held in with a screw to keep these from twisting, because if one of them could twist, they could screw apart from each other. And that preloads them together to reduce the backlash. Now with the C7 screws that I had in the Grizzly, there's enough lead error that these shims had to be a little bit loose to accommodate that. Otherwise, any place along the screw where the lead was a little bit shorter or squeezed together, the nuts would jam. So they had to make the shims in here a little bit thinner to accommodate all of the lead error along the length of the screw. Since these are C5 instead of C7, the maximum lead error is lower, and so they can load these tighter. And these don't have any perceptible movement that I could feel. The C7 screws that I had previously, I could feel that. Now these do have a lubrication port. This is an M6 thread, and it's just got a set screw down in it to plug it. But this is for adding lubrication to the inside of the ball nut. And they come with grease in them, but I'm planning on running oil. And the kit does come with these little spring ball fittings, typically used for grease. I believe you can use them for oil as well, but when this thing is installed, there's going to be no access to this. So we're going to need to hook tubes up to the oil ports. And that is the challenge, because when this thing is in the machine, there's not going to be a lot of clearance for that. So I've ordered some right angle push to connect fittings for 4mm tube. We'll see if those are going to fit. Otherwise, we might have to make something or repurpose something. I know for the Haas machine conversion on the Geo704 back in the day, he recommended using these little nylon elbows from McMaster Carr that are actually 1/4 28 thread instead of M6, but you can force them in and they kind of recut their own threads, and it's a very low profile way to attach a line. We may end up doing that. I actually designed my own little elbows and 3D printed these on a resin printer, and unfortunately that's not going to work out because I got these all done. The strength is there, they work great, they fit great, and then I found out that the material I use is not resistant to oil, so it'll just soften and go to mush. So that's not going to work. I've got some printing on an FDM printer in nylon. We'll see if that works, but otherwise we may have to make something out of brass if the commercial fittings that should be arriving later today won't fit in the available space. The kit comes with everything you should need to mount the ball screws, though we'll find out when we actually try to do it. So it's got cast iron, machined, and finished mounts. This is the one for the Z motor on the top of the column. We've got the bearing blocks and all of the other mounts for the motors on all of the other axes, if I can get them out of the foam. And the way these work is they use angular contact bearings that are pressed in back to back and squeezed together. And you'll note these bearings, if you look at the outside wall, it's thin on one side and it's thicker on the other. And that's because there's a larger ledge on one side than the other, because these are meant to take axial forces. And so there's writing on one side of the bearing, none on the other, and so you take a pair of these and you load them in so that the writing faces inward. Then the ball screw goes through, and then you put a nut on. And the tension of that nut is really important for actually setting the preload on these bearings so that there's no backlash end to end. And there's a couple of different ways this is usually done. This kit has some little adjustable lock nuts. So these nuts go on the end of the screw, and you can see there are little set screws in them, and I don't know if you can see that little yellowish tinge in there. There's actually a brass slug behind the screw. So if you, as you tighten down the screws on opposite sides, they clamp down onto the ball screw. So you can tighten this down as tight as you need it so that you get smooth movement but zero backlash, and then tighten those screws to set it so that it won't slip. Now this is better than what I had on the Grizzly conversion for the Z-axis at least. They had this kind of a configuration and you just had a nylon lock nut and you had to tighten it and adjust it and hope for the best. This will probably work well enough. But the way that you would do this in more than a hobby application is you would usually put a ground spacer between the inner races of the bearings, so that when you tighten the nut down, you just tighten it down fully, and those inner races press against the that ground spacer, and the outer races press against the housing, and that sets the preload. So you actually bottom it against the spacer, and if you need to change the preload, you change the spacer. You can also run the bearings back to back, actually in contact with one another, and they can either be factory ground for that, or you can put a shim between the outer races to get the preload that you want. In this case, we'll just go ahead and run it with these nuts. They seem pretty nice, and we'll see how well it works. And if I run into problems, I have a grinder. I can make ground shims. We can always address this later, but I think this will probably be good enough. A couple more things I'll mention about the kit. It does come with hardware and sheet metal parts. And these are dust and chip guards to go over the motors and the linkages just to keep the chips out. These do limit the size of motors that you can use, particularly on the X and Y axes. I went ahead and got motors that I think are going to fit underneath these. We will see how that goes, and if I have a problem, I will adjust or make new sheet metal parts. This also comes with couplers for the motors. And these are what are commonly referred to as Lovejoy couplers. They're 2 halves. That then have a slightly flexible, fairly rigid, like a nylon or a polyurethane spider that goes between them to take up the slack. I don't prefer this style of coupler. I got some other ones that I'm planning on using, but I'm sure these would be just fine. These just require you to have it very precisely aligned with the motor, which we can do. We'll just put it together, line it up, and then tighten down the screws. But you get a lot of sideways forces on the bearings if things are not precisely aligned. And so I prefer to use an axial misalignment coupler that allows just a little bit more freedom, but that's neither here nor there. It's just a personal preference. Looking down into the top of the column here, we have the Z crank and the set of bevel gears that drive the vertical screw. Now I think this whole assembly comes out the side, but I can't get it out with the bevel gear on it because the bevel gear is too large to fit through the opening. So I think we just have to take out the set screws. Is there more than one? Yep. And that should allow us to pull out the shaft. And it looks like no, that will have to come off, but there's a little circlip in there first. So let's take the nut off of the top bevel gear here and see if we can get that out. I think we just have to drive that down out of the bevel gear. Get a piece of aluminum rod here so I don't mar anything up. Wondering if I'm missing something. Yep, there's a screw. There's a set screw. There we go. And there it is. And what do you know? There's actually a thrust bearing that I was hammering on. Good job. Good thing I don't need that. With that out, I can take out this bevel gear and the key, and then this whole assembly should come out. Could probably take this handle off and make these screws easier to get to, but I don't want to. Okay, there it is. Now, I'm curious, did I actually have to take the gears off? And yes, I did. It won't fit through the hole with the gears on. So now that frees up the screw, and all we have left is the nut that is attached right here. So we should have to just take out this one screw, and it should come off the back, and then we should be able to take the screw out the top. Let's see how well I understand the situation. Okay. And yes, that's how it works. The nut just attaches with a single screw, and there's a little boss that fits into a machined recess on the back. And the ball screw kit comes with its own that should fit into that same space. Now I'm going to go put all the bearings and everything back on this and reassemble it so that I don't lose any of the parts. Okay, I've got the Z ball screw assembled to the nut exactly as it's shown in the diagram. There's just 4 M5 screws with lock washers and washers through the flange into the nut, with the flange down so that it's sitting underneath the nut. And this should use exactly the same screw to attach it. So we just need to drop this in and put in the screw. Now I did choose to orient the oiling port towards the back on the right hand side, or I guess the left hand side when viewed from the front, just because looking in the casting, I think there's going to be plenty of room for the oil line if I do it in that direction. Okay, I think that's right. I'm not going to tighten this down yet because I want to wait until I'll tighten it at least snug. And then I want to get the bearing stack and assembly installed up here on the top so I can run it all the way up and down and let things float before I tighten everything down, just to make sure that I don't have any binding. Okay, I've got the cast motor base here and the bearings and the nut. Now, somebody tipped me off that this part is not symmetrical. So if you put it in the wrong way around, it'll pull the screw to one side, looks like towards the front as the column comes up, or maybe the other way around, we'll see. And it will actually snap the screw and drop the head. We definitely do not want to do that. So we'll put the bearings in. The side with the lettering goes in. So for the bottom bearing, that's up. And these are a very, very close fit. They have to be aligned perfectly, and then they just drop right in. Just like that. And the top one has the writing down. Okay, I think that's the direction it goes, but I'm going to go ahead and raise it all the way up just to be sure. And yeah, that's completely wrong. This is definitely the correct direction. So let me get some screws. Okay, we'll bring that all the way up there. And tighten that. Then we'll loosen and retighten these. And then loosen and retighten this. And we'll do a couple of rounds of that just to make sure everything has settled in and aligned where it wants to be. Oh, that feels really nice and solid. Much, much freer than it was a moment ago before everything was aligned. Okay, I think I'm going to call that good. Let me see if I can tighten this nut down a little bit and put in the set screws on it. Okay, that's Z done for now. Once we have a motor on it, we'll run it the full length and check the, we use the USB controls on the clear path to look at the torque being delivered and just make sure that nothing is binding. But I think that is Z done. Now we need to dig into X and Y. And I think the easiest way to do this is going to be to just take the brackets off the ends of the table and then pull out the gib so that the table can lift off, and then do the same thing for the Y-axis. Start by getting rid of the locks. We won't need those. Yep, and those just rotate out of the way. Now when I got the mill, the table was actually really tight going to that end, and that's because this bracket on this end was misaligned. So I just loosened these two screws, ran it all the way over so the nut that's fixed in the middle was close to this end of the table, caused it to line up, tighten that back down. And we will want to do the same thing once we put the ball screw in. Okay, now the table's disconnected from the screw because it's just attached by these blocks on the ends. So now, if I understand everything correctly, I should be able to just pull the gib out. I'm going to mark the top of that. One little mark in the end just to let me know that that is the top. And then I should be able to just lift off the table. It looks like maybe there's not enough clearance on this one. And there you can see how this works. The nut is just fastened down right there, and then the screw goes to the ends and bolts onto the ends of the table. Okay, I'm going to do exactly the same thing to take the saddle off. This is the screw that holds it down to the nut on the Y screw, and we'll pull the gib out to make room to actually get this off. And we also need to take off this oil line. Those are nice little wipers. I'll do the same thing and mark the top of this. And then this is the screw that holds the nut to the bottom. Then we'll loosen the screws on the front of on the front here so that the screw can tip down and clear. And we have the same situation. We're going to have to pull this thing all the way out. Just running the nut here all the way to the back, just to give me more clearance. Okay, and then I'm just going to go ahead and take the nut off of this so I can pull the screw out without disconnecting the bearing block. Let's turn it the correct direction though. Now I don't want to do that with the ball screw because then the nuts will all fall out and nobody wants that. We'll see if I can manage to get it in without that. I think this hole's big enough we'll be able to do it. I've got the Y lead screw, or the Y ball screw assembled. Again, double nut screw. We've just got some M5 by 25 millimeter screws into the nut that came with the kit with lock washers and washers. Now, I played around with trying to figure out where I wanted the oil port and decided it has to be on the bottom. The other place it could fit is right here on the top, but there just isn't clearance on the top side of the nut for there to actually be room to have the connector and not hit the underside of the saddle. So it's going to be on the bottom, and then what I'll have to do is have the oil line exit the bottom, loop up, and I'll drill a hole through someplace right here where we can actually get it out the top. But the screw will just fit in like this. Now, incidentally, when I did this conversion or a similar conversion on the G0704, there wasn't really room to get this in without taking the nuts off of the screw. So you have to have a plug the right size to screw it onto, and I messed around with 3D printing it, but back in the day, the 3D printers weren't very accurate, and I spilled all the balls, all the balls out of the nuts, and it was a huge mess. This, because of the size of this hole in the front, can be inserted without having to do that. And then I've got the front bearing plate already loaded up with an angular contact bearing that also came in the kit. Words to the inside. Put that on here. And we'll put the lock nut on. And actually that feels pretty tight. I'm just going to go ahead and lock that down. Very good chance I'm going to have to adjust this later anyway. And this comes with new screws, no washers, so that there's a little bit of adjustability here, so we can do the same thing. Put the saddle on, bring it all the way forward, let this float, and then tighten it down. Now, as soon as I get my fittings, I am going to have to take this apart to put the oil lines on it, but for now, I'm going to go ahead and just put it together and make sure that everything fits, because I'd hate to get all the oil lines and everything hooked up and then realize I have to do some machining or something. Actually, it feels pretty good. It's about the same tightness all the way from the front to the back, which is exactly what you would want. Okay, now we'll just run this all the way to the front, back it off of the hard stop slightly, let everything align, and retighten all the screws, just like we did for the Z-axis. You know, maybe I should put a motor on this. Okay, there's the hard stop, back off of it slightly. Trying to feel if the screw's moving at all as I tighten this, and I'm feeling nothing, so I think we're good. Oh yeah, and that's still nice and easy to turn. Yeah, it feels great. Front to back, nice and smooth. Of course, I don't really have lubrication on the ball screw yet, so I don't want to run it too far, too fast, but that's enough. And have some confidence that everything is aligned. Okay, for the X-axis, I've got exactly the same thing going. I've already assembled the nut into the screw, and it's on its bracket. I elected to put the oiling port right here on top. I probably could orient it downward and get something on it, but I think that's going to be pretty tight, especially since it would have to be against this bracket. So I think the oiling port on the top side here is going to be fine. I can put a 90-degree fitting on that then comes out in this direction, maybe even angles a little bit downward, and I'm pretty sure that'll clear the underside of the table. I guess we will find out. And this is just held down with 2 screws that came in the kit. Now this one is not ideal in terms of the way I'm trying to align these things, because I have to put this down with 2 screws, and that's going to set the angle of the screw. And I can't then necessarily line it up so that it's perfectly parallel with the travel of the machine, because I don't have the ability to loosen these and then tighten the end brackets and run the table back and forth and let it find its center, which means this is going to need to be adjusted pretty carefully. The best I'm going to be able to do is just dial one of these surfaces and run the table in and out and adjust that with a dial indicator. So that's what I will do. That is perfect enough. Okay, let me get the table. Okay, now we need to attach the ball screw on this end to the table. The actual thrust bearings, the angular contact bearings, are on the left. The motor is over on the right. So there's actually no support for the lead screw on the right end. It's supported by the motor, which means I can't use the special couplers that I bought. I'm going to have to use the ones that came in the kit. It was an oversight. I didn't realize that, but we can go ahead and put in the angular contact bearings on this end. You can probably hear the air conditioner running in the background. It is that time of year again, and I'm just going to keep working. So this is the bracket that came in the kit, and it's the same sort of deal. There's 2 angular contact bearings. They go wards inward in either side. Now, while the fit was really close on the other ones, the bearings just dropped right in. On this end, they did not. I measured it with a 3-point mic, and it was like 1 or 2 hundredths of a millimeter interference fit, and that was caused by the paint. So I just used my little NSK pencil grinder with a wire brush and took the paint off of the inside, and now the bearings just very nicely slide in. Once you get them aligned. Come on, there it is. This will be the same deal. This goes on, and then we put on a lock nut. And this probably will need to be adjusted later. And then that attaches to the end of the table. Okay, now I'm just going to run this down to the far end, which might be easier said than done. In case you wondered, this is not how you're supposed to do it. Okay, that's as far as I'm going to go. I'm going to go flush there, and we'll tighten it down and we'll call it good. There we go. Okay, we've got a laptop hooked up to the motor here, and we can move it around a little bit. So I just click, we're moving, we're not going very fast. I'm just going to run it down here flush. I've been doing a little bit of testing here with the camera turned off, and I've got this thing dialed up now to moving 400 inches per minute, or the metric equivalent thereof, which is the motor running at 2000 RPM on a 5mm pitch lead screw, 20,000 RPM per second acceleration, and just doing a couple of quick moves. And that's running at about 30% motor torque on this little motor, so I'm pretty happy with that. And that's without any lubrication on the ball screw. Well, there we go. It is actually moving. There is lots more still to do. I'm still waiting on the parts for the oiling system. They did not get here in time. I was really hoping they were going to get here today, but it looks like they are not. So we've got all 3 ball screws installed. We've got the motor on the X-axis just because that's what was required to support the ball screw. We still need to get the motor on the Y and the Z and the brake on the Z, but I'm going to tear this all back down and do the lubrication system on the ball nuts first. So that will be coming up in a future video. Unfortunately, this is as far as I'm going to get today, but we made great progress, and we'll keep going in a future video. Thank you for watching.